Hello and good day, pre-algebra. We are wrapping up Unit 2 with CO12, using what we used in CO11, because in CO11 we have those two charts. One lists all those perfect squares and their root. We're going to look today at how we can estimate the value of a non-perfect square. So if you look for 34 on that chart in CO11, you're not going to find it. Right? You see a root 36, which is close, but you're not going to see a root 34. You won't see a root 180. You won't see a root 5. You won't see a root 68. Right? So how can we estimate these values using what we learned in CO11? That's the goal for today. But we're going to start with, if I tell you the area of a square is 25 square yards, how do you know what the measure of its sides are? Right? Here's our square, kind of rectangly, but just pretend. The area is 25. How do you know what the measures of the sides are? The answer is kind of think about, well, how do I get to the area of a square? Right? What's the formula to calculate the area of a square? Yeah. Times what? What do you multiply? So the area of a square, what is that formula? What are you multiplying together to get there? Length times width, or base times height. Right? So somehow we got to 25. Knowing the area is 25, we got there by multiplying the base and the height together. Right? Now, knowing this is a square, what other piece of information do we know about the side lengths? Like, what's kind of unique to that square when we multiply the base and the height?
Like all the sides are equal.
All the sides are the same. Okay? So really, we can think about this. We know the area is base times height, but if the base and the height are the same, then really whatever the base is, we can just multiply by the same thing. And what's another way to write b times b? We're multiplying something times itself.
Exponents?
Use an exponent, right? B times b equals b squared. Does it not? Okay. In fact, that's where that term squared comes from. You know, why is it a power of 2? Why is it squared? Because when you find the area of a square, you're multiplying something times itself. So knowing that the area is 25, what number times itself would get us there? 5. Right? 25 is equal to 5 squared, which means that the height and the base of this square are both 5. Okay, that's where that term comes from. And then with a power of 3, what's the term for a power of 3, an exponent of 3? Cubed. Why is that? Well, because when you find the volume of a cube, a three-dimensional shape, you're taking length times width times height, right? To find that cube, you're multiplying something times itself 3 times. Okay. Now, the second one here, the area of a square is 34. And again, I ask you for the measure of its sides. What times itself is 34? Not as easy, is it? Right? Because like we talked about, if you look back at your chart in the previous page, we see a root 36, which is 6 times 6. We don't see a root 34. So here's where the estimation comes in here, right? On your homework, you're going to be required to show work. Again, you will not be able to use a calculator on this section of the test. So I do not recommend using one to find your answer now. You can use it to check your answer, but not find it. So what we're going to do to find the estimation for the value of the root 34 is we're going to use that chart from CO11. And we're going to say, what two perfect squares does root 34 come between? We know it's that root 36, right, is just above it. What perfect square is just below it? 25. Okay, so you should be jotting these notes down now because this is the work I'm going to want to see on the homework, and it's also how to kind of logically think through this here. So root 34 is not a perfect square, but because it comes between the root of 25 and the root of 36, we know its value has to be between root 25 and root 36, right? So the root of 25 is 5. The root of 36 is 6, which tells us that the root of 34 is somewhere between 5 and 6. Okay? Some decimal, some value between 5 and 6. So now we look at, okay, is root 34 closer to root 25, meaning it'd be closer to 5? Or is it closer to root 36, meaning it's closer to 6? What is 34 closer to? It's closer to 6, right? Because 34 is only 2 away from 36, whereas it's 9 away from 25. So because it's closer to the root of 36, that means it's going to be closer to 6 than it is to 5. So give me a decimal value that would be a good approximation for the root of 34. Like, I wouldn't want to put down 5.1, right? Because 5.1 is closer to 5. I wouldn't want to put down 5.5 because that's right in the middle, which it's not. 34 is clearly closer to 36. Sure. 5.7, 5.8, 5.9. I mean, this is just an estimation, so we don't have to be exact, right? But we're just given a ballpark for it. We have to be, within the ballpark. Like I said, I would not accept 5.5 because that's you telling me it's right in the middle, which it isn't, but 5.7, 5.8, 5.9, somewhere around there, okay? So again, knowing these perfect squares is going to be very important, which is why that table being a key point, put it on your help sheet. Okay, put it on your help sheet. Take the time to put that on your help sheet. The root of 180. What two perfect squares does that come between? What's the next smallest perfect square? What's the next largest perfect square? And take a look at your table. What's yeah? 169. Good. 169 and 196. So the root of 180 is going to be somewhere between those two values. What is the root of 169? 13. And the root of 196? 14. Okay. So the root of 180 is going to be somewhere between those two values. Well, the question is where? Right? Is 180 closer to 169 or is it closer to 196? Tristan?
It was definitely closer to 196.
Why do you say that?
Because 169 is a bit farther than 196 because if you subtracted it from 196, it would go down to 180.
Okay, so how far away is 180 from 169? It's 11 away, right? If we kind of look at this distance, it's 11 away here. How far away is it from 196? 16. So actually, it's going to be closer to 169, right? It's closer to 169 because 11 versus 16, the 11 is going to be closer, okay? Which means for our decimal, it's going to be closer to 13 than it is to 14. What would you estimate? 13.1. I mean, if the Packers had won this weekend, I would accept that, but it is, more in the middle. It's not 13.4 would be a better estimation. 13.3. Again, 13.2. That's getting a little bit out there, okay? But it is pretty close to the center. These two numbers aren't that far. Like here, it was 2 and 9. 2 is much closer than 9. That one's a little more tight, but it's definitely on the left side of 13.5. It's less than 13.5. Okay, now you've seen two of them. Any questions you have? Okay, it is helpful to show the work, right? Which is why I'm requiring you to do it for your homework here. That table's gonna be helpful. Right? Root of 5. Do this one on your own. I'll give you 30 seconds. This is where I need that music to play. The Jeopardy music or something. And we start by going back to CO11, which if you weren't here Tuesday, then get those notes from a friend. Okay, Peyton, Mia, anyone else not here on Tuesday and don't have these notes? Okay, so either watch the video or grab them from a friend so you have these values here. But the root of 4 is the next perfect square below root 5. Root of 9, next perfect square above it, which means that the root of 5 is between 2 and 3, right? And what estimation did you ultimately come up with? Josie? 2.1? Penelope? Did you have your hand up? Oh, Nolan? 2.2? 2.3? And this one actually, even though it's really close to 4, it's only 1 away here versus 4 away here. It's definitely close to 4, but our total difference is only 5, right? From 4 to 9 is only a space of 5, whereas here it was 27 away. Here it was 11 away. So since the overall distance is so small, 2.3 would be a perfectly acceptable answer. I think it actually ends up being something like 2.25 or 2.28 or something like that. But I would also accept 2.1. Yeah.
Do you also try to divide it?
What would you divide it by?
2.
No. A square root does not mean divide by 2. Right? That's the, if you want to get Mr. Schultz going, think that a power is multiplied by 2 and a root is divided by 2. No. The only root, and this might be the only root for which that works, or you can just divide by 2, is the root of 4. But that's the one exception, right? Otherwise, it's what number times itself. And it so happens that it's because 2 times 2, does equal 4. But no, root does not mean divide by 2. Root 68. Try this one on your own. Even if you don't have these notes and weren't here on Tuesday, here are the perfect squares you're working with. So take it from here now. Root 64 is the next smallest one. That's 8. Root 81 is the next largest one. That is 9. So finish it from this point because you don't need the notes from Tuesday to take it from here now once you got those two perfect squares. And if you're done, you're feeling good, you want to go on to the rest of the objective, that'll be your homework. I might nix some of them, so stay tuned, but you can start to work ahead, show the work. It's going to be required. If you do not have work shown tomorrow, you will not get credit for the assignment. So make sure you are showing the work. This is the work that I want to see. You don't need to put down 3 answers, right? You only have to put down 1. But I need to see that you're identifying the next smallest, next largest perfect square, kind of the range, things like that. So it's between 8 and 9. Who wants to share what they came up with here? Tristan.
I would think it would be 64 because it's only 4 away from 68.
Okay, so it is closer to 64 than it is to 81. right? 4 away versus 13 away. And so what estimation did you ultimately come up with? Nolan? 8.2 would be good, right? Knowing that it's closer to 64, it's going to be closer to 8 there, right? So we got 8.2. Anyone else put something different? Okay. 8.3 would be fine. I'd accept 8.1, right? Somewhere around there. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Very well. All right. Your homework for tomorrow, and again, tomorrow we'll have a practice test. The test for Realsies will be on Wednesday. But for tomorrow, you've got some more to practice here. The exact same stuff we did up at the top of the page. Okay, nothing changes except obviously the roots. But you're looking for that smallest, largest perfect square, looking for that range, estimating that decimal value. More on the back. Okay. 2 word problems, which have to do with 3 word problems, but have to do with the 2 questions at the beginning of the page, where we found the area of that 34 square, right? You're finding the square root. When it says a square bulletin board is an area of 66 feet, what is the length of one of its sides? Here's your square bulletin board. You know the area is 66. You need to estimate the root of 66. What times itself, right? What times itself equals that area of 66. So it's the same concept, just kind of presented a little bit differently. Then some review at the bottom. What is the order of operations? And explain how a radical is the opposite of squaring. Remember, in PERMDAS, that E and the R, they're opposite operations. How are they opposite operations? Okay, how are they opposite operations? And then this section here, this brain buster, we're working backwards. I'm giving you a decimal value. You're giving me a possible root value. So if the decimal estimation is 2.7, what root value could possibly give us 2.7? We're kind of working backwards here, right? Here's our range between 2 and 3. 2.7 is like right here. I know that 2 is the root of 4. I know that 3 is the root of 9. What root would be a potential value that would give us 2.7 as a decimal? Oh, sorry, thought your hand was up. And same concept, just kind of backwards here. Here's my decimal range from 2 holes to 3 holes. 2.7 is right about there. If I know that the root of 4 equals 2 and the root of 9 equals 3, what possible root, not a perfect square, obviously, it's not going to be on your chart. It'll be somewhere between root 4 and root 9, but what would you say? Scarlett? Sorry? Root of 5? Root of 5, it's closer to 4 than it is to 9, so the root 5 is going to be somewhere down over here. How about one that's closer to the root of 9? You're in the right ballpark, but now we got to just kind of narrow it down a little bit further.
7.
Root of 7, possibly. Okay. What else? Zoe's got a hand up? No? Root of 8, right? Is that what you're going to say, Mia? Root of 5. Again, root 5 is a little bit closer to 4, so the root of 5, that decimal is going to be more like 2.1, 2.2, 2.3. We're looking for one that's closer to 9. Root 7 is closer to 9 than it is to 4, right? So it kind of makes more sense there. Root of 8 would be another one, right? Closer to root 9, closer to 3. How about root 10? Would root 10 work? Tristan?
It probably would because if we have a time, it's only one way away.
It's one way, but which side of root 9 is it? Root 10 is over here, right? Which means that its decimal value is going to be on that side of 3. That's going to be like 3.1, 3.2, something like that. Okay, so you really have to hone in. Part of it is how far away it is, but the other part is, does it fall within my range of roots? Let's check another one here. Let's look at 7.1. Okay, what two integers is 7.1 between? What two numbers is 7.1 between? Don't make me do this. Is that a hand up? Thank you. I was about to call down to first grade again, like I had to do last week, right? Ask them what numbers 7.1 between. All right, 7 and 8. And what do we know about the value of 7? What root, what perfect square has a value of 7? 49. And what perfect square has a value of 8? 64, right? So what we're doing here is we're developing this range, okay? We want to know what root would estimate to be 7.1. We're figuring out what range of roots our answer has to be between here. Knowing that 7.1 is between 7 and 8, knowing that 7 is root 49, 8 is root 64, we know that the root that equals 7.1 is somewhere within this range of numbers and that range of roots there. So what would you estimate? What would be a good estimating root here? Root 60? Good estimation, bad estimation? Is that a thumbs down? Thumbs down. Bad estimation, right? Root 60 is closer to 64. 7.1, that's right up against 7 there. I'm looking for something that's way over here. Root 51 would be a good estimation. What else? Root 50? Sure. Root 52? Yeah. Right? Okay. So a little bit same idea, just kind of flipping that process there. Homework is the rest of CO12. You will have a homework check on this tomorrow. If you did not get at least 4 out of 5 on the homework check for today, make sure you get back in later on this afternoon, evening, and fix it so you get the point. And with gusto, I'm a little nervous today, but you can do it. Pull it together. With gusto, that's how you math. No, that's what I say. Thank you. Oh, boy.